Welcome to myprojectbazaar.com.
Our product title is Improved Energy Storage Management and PV Active Power Control Infrastructure and Strategies for Microgrids. Let us see about abstract of our product. Microgrids can be defined as distribution systems with distributed generation units, energy storages and controllable loads. The ancillary services that could be provided by the distributed generators and the energy storage systems are expected to give great added value to the microgrid based smart grid topologies. These services must be integrated into the control system of the microgrids. In this proposed implementation design is introduced the pseudo state of charge concept to improve energy storage management. Additionally, a non-invasive to the inverter PV plant control strategy based on the remote control of PV strings actuators is presented and applied on a microgrid based smart grid topology. This operation of the microgrid with the improved control infrastructure and iterative algorithm is compared in terms of reliability to a microgrid with a different control strategies and topologies. The experimental results highlight the advantages of the developed strategy. In this implementation is done in MATLAB simulating environment. Next we see about flow diagram of our product. In this flow diagram generally consists different kinds of distributed generation such as PV panel, wind generation, battery bank units, and also they are having 5 kinds of controllable loads, and also the output of the generation units fed into the distributed bus, and also that are all merged in a grid. Initially the PV panel is generated the DC voltage, and that DC voltage is converted into AC using of inverter, and that AC voltage is fed into the distributed bus and to grid unit. And also wind generation is generated the AC voltage, that AC voltage is fed into the rectifier unit. In that rectifier unit that voltage is rectified into DC, and that rectified DC voltage is stored in the battery charger, and also the output is fed into the battery charger and inverter unit. And from the battery bank output of DC voltages is also fed into the battery charger and inverter unit. In that unit that is fed into the distributed bus, and also finally it goes to the grid. And also the load, various kinds of load 1, load 2, load 3, load 4 and load 5, that loads are connected in a distributed bus, and each loads is separate load values, and also the overall control is controlled by the control algorithm for our convenient, and the pulses is generated using a space vector pulse width modulation and sliding mode controller. So those controller developing the pulses, that pulses is fed into the corresponding IGBT or MOSFET switches in the converter units. Next we see about running process of our product. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB window and create a new model file. After creating the new model file, we arrange the elements as per the circuit diagram. After arranging that, we click the run icon. The corresponding output will display in the corresponding connected scopes. The first one is the output of PV inverter 2 output voltage and output current waveform, and the next one is the PV inverter 1 output voltage and output current waveform. This value is 0 because this inverter is on only this duration only, so other this duration that inverter will open, so when the open circuit the current will be 0, so the waveform is like that. Next one, this is the separate voltage A, B, C voltages, and the next one is the corresponding grid voltage waveforms, and the next one is the pseudo state of charge output. This is the actual SOC, this is the estimated SOC using of pseudo state, and the next one is the battery current is getting from the output of wind generation unit, and next one is the grid output voltage and current waveform, and next one is the state of charges. This is load 1, load 2, load 3 and load 4 and load 5 switching states, and the load 1 is only operating during a zero point 0.5 seconds, and load 2 after 0.5 to 1 seconds that load is on, the load 3 is on 0.25 and off condition and on condition and off condition, like this. And next one is the grid connected state. This is rectifier connected state, battery bank and voltage converter 1 and PV converter 2. And next we see the output of load voltages. This is load 3 voltage waveform, this is load 4 voltage waveform, and this is load 5 voltage waveform. And next one is we see the current waveform for different kinds of loads, load 3, load 4 and load 5. Generally the switching states, whenever the load is on and off, we decide for these corresponding pseudo state conditions. Thank you for watching this video.